In this graph, they say that the first pattern there are 3 dots, and then the next pattern will be the previous one additional add 2. So you find that every time we just add 2, we get another term. We have to find the least value of m such that it fulfills certain requirements. So before we work on this, the key point is you have to realize what kind of sequence it is. You learn about AS and GS. Now here we are talking about adding the same number every time, so it is AS. For AS, you know that the n term is equal to a and then plus n minus 1 step. And in AS, the step that means every time plus d. And then after that, that means we have the term already. A little bit more is we know Sn is equal to 2a plus n minus 1d times n divided by 2. First term plus the last term times height divided by 2. You must memorize this before your exam. Now we look at the criteria. They say that m such that the total number of dots, that means the number of dots in the first one, together with the second one, together with the third one, until the n one. In the first m pattern exceeds this amount. So the total number here representing Sn instead of just single term. Therefore, it's given that Sm is exists 6888. Pay extra attention should you include the equal sign. They say exists, that means more than, so no equal sign here. Then we can continue to work here. We already know that a, the first term is 3, while the difference is 2. You may just substitute one by one based on our formula. So we substitute the value to a plus, now not n but m. And then I just feel more comfortable to substitute step by step. So a here is talking about 3, while d here is talking about 2. So it's form an inequality with m be the only variable, and also it is a quadratic because we find m times m here. But anyway, we just simplify first. M squared plus 2m, and then for quadratic inequality we put everything to one side, and then another side is 0. Now we are talking about when is this quadratic expression larger than 0. So in our graph we are considering a quadratic function and compare with the roots here when it is equal to 0, when the whole thing equal to 0. We can use formula 0, 1. Then we find that one of our roots is 82, while another root is negative 84. Negative 84 is smaller, so it's placed left hand side, and 82 in right hand side. We are talking about when this curve is above the ground. When this curve above the ground, then obviously we are talking about this region and also this region. That means your input, it can be larger than 82 or smaller than negative 84. So that's why this quadratic inequality, our result is m may be smaller than negative 84 or m may be larger than 82. If m is not too large, not too small, for example m is equal to 2, then it do not fulfill the requirement and give you negative value in the quadratic expression. But anyway, m is an integer. Here have the same domain as positive integer n, so this is just simply rejected. It can't be negative. And then we are going to find the least value of m fulfill this requirement. Beware that we don't include the equal case, so it can't be exactly 82. The least value is equal to 83. You can choose 83, 84, but among those numbers, the least value is 83. That's how you solve it. First, to realize that is that AS or GS, and then brainstorm those formula, and then focus on the given criteria. Try to evaluate the criteria, and then you find something which is inequality, and then depends on the inequality, is that linear or quadratic. Use your own method to solve it.